day in our life as a civil engineering student! So ngayon, mga ka-CE, hindi muna tayo magpapakita ng kastresan sa buhay.
Tama, magpapakaseryoso muna tayo ngayon.
Seryoso?
Yung mga sineryoso.
Oh my gosh, I'm stressed. Hi! Your typical vlog as engineering students. Today, we're diving deep into the world of construction sites, where the real action happens.
That's right. This vlog is all about gaining knowledge from experts in the field. We're here to explore complex details sa mga nangyayari sa construction sites, from groundbreaking hanggang sa finishing touches.
So get ready to expand your understanding and learn from the best as we dive down sa world of construction engineering with Sir David, Pineda, and Santos.
So, what does it feel like to work as an engineer?
Sa totoo lang, ayoko na eh. Sobrang init and medyo delikado rin. Joke lang! But well, working as engineer can be incredibly rewarding eh. It involves problem solving, creativity, and innovation. You get to see your designs come to life and have a real life impact on the world around you.
So the focus of this interview isn't just about being an engineer or designing dream houses.
So, as engineering students, we want to dive into the topics of stress.
So we have some questions about stress, especially about sa mga steel bars. You just need to answer them and we'll move on to the next question. Are you ready?
Game!
Alright, let's dive into our Q&A portion about stress, particularly focusing on steel bars.
So first, pwede niyo ba kaming bigyan ng konting insights about stress? At ano ang mga pwede namin malaman bago tayo mag-proceed sa susunod na tanong? Sir David?
Sure, Charm. Pero bahala na si Engineer Pineda mag-explain about sa stress.
So meron tayong prepare na PowerPoint presentation dito para mas papalawak pa natin ang ating kaalaman sa iba't ibang uri ng stress. So ano nga ba ang stress?
Meron tayong iba't ibang uri ng stress. Meron tayong tensile stress, which occurs when materials are pulled or stretched, causing elongation. Common in cables and bridges. Design consideration include selecting materials with high tensile strength and proper reinforcement. Then we have compressive stress. Happens when materials are squeezed or crushed, causing shortening, common in columns and beams. Design consideration involves selecting materials with the high compressive strength and designing structural support to prevent collapse. Third is shear stress. Arises when forces act parallel but in opposite directions, causing sliding, common in bolts and rivets. Design consideration includes selecting materials with high shear strength and proper fastening techniques. At pinakahuli ang torsional stress. Occurs when twisting or torque forces leading to deformation along a spiral path common in shafts and gears. Design consideration involves selecting materials with high torsional strength and proper shaft geometry. So lagi natin tandaan, ang tensile stress is pahila. Ang compressive stress is pa-squeeze or pa-crush. Ang shear stress is pag-slide or nagkikiskisan. And lastly, ang torsional stress is yung paikot. Yun lang lagi natin tatandaan.
Thank you, Engineer Pineda. Ang stress analysis, importante yan sa field. It allows us to evaluate how materials respond to external forces and ensure that our designs meet safety standards.
Tama yung sinabi ni Engineer David. Stress can affect the performance of structures sa maraming paraan. Kaya sa pag-aaral ng stress distribution at materials behavior, makakagawa tayo ng design na makakaya ang iba't ibang uri ng bigat or loading conditions.
So, Engineer Harold, could you shed some light on how steel bars experience stress, particularly in compression?
When steel bars are subjected to compressive force, they experience stress that pushes the particle closer together.
Gusto ko lang dagdagan yung sinabi ni Engineer Santos. Ang steel bar kasi is a ductile material, kaya ang ibig sabihin nun, dedeform yun kahit sa anong pressure, pwedeng compressive, pwedeng tensile, pwedeng torsion, or ano pa. However, it's crucial to ensure that the applied load doesn't exceed the material's compressive strength to prevent failure. Halimbawa, meron tayong bakal na nasobrahan ng load, so pwede siyang maputor, mabali, or ma-deform.
So, Engineer, pwede nyo ba kaming bigyan ng mga real-life example or scenario na yung mga steel bars is going to undergo compression stress?
Pwede naman. For example, ang buildings niyo sa Holy Angel University, meron kayong PGN at APS buildings doon. So, meron tayong mga columns dyan na kayang supportahan yung buong bigat ng building na yon. So, nag-exert yun ng compressive forces sa mga steel bars sa loob ng columns na yon. Sa pagdidesign at paglalagay ng mga reinforcement, makakasigurado tayo na kaya niyang buhatin ang buong building nang hindi tumitibag, nagkakaroon ng bitak, o nasisira for a long time.
Maraming salamat, Engineer Angela. Now, Engineer Harold, as our expert in structural design, how do engineers account for compression stress when designing structure with steel bars?
Kami mga engineer ay kinoconsider namin ang mga expected load at building code. At ang mga structural designer naman ay kinakalculate nila yung spacing ng steel bar to ensure they can stand in anticipated compression stress.
Thank you, Engineer Santos. Now, Sir David, from your experience, how do you ensure that steel bars are installed and maintained to withstand compression steel effectively?
Ensuring proper installation and maintenance of steel bars is crucial for structural integrity. During construction, quality control measures are implemented to verify the correct placement and alignment of bars. Regular inspections are conducted throughout the lifespan of the structure to identify any signs of deterioration or stress concentration.
Thank you, Engineer Andrew, for emphasizing the importance of quality control and maintenance. It's clear and managing stress in steel bars is multifaceted process that requires expertise from various engineering disciplines.
Ano ba yan?
Ben, paano ka? May nangyari ba? Nag-away ba kayo ng jowa mo?
Hindi be, hindi ko lang makuha tong activity namin sa Mech. About stress siya eh.
Ganun ba? Ganyan din ako eh. Hindi ko maintindihan.
So, paano na to be? Kailangan ko makuha to, bumabagsak na kasi ako sa Mech eh. Kailangan ko siyang reviewin.
May i-recommend ako sa'yo. Civil engineer siya, then meron siyang blog. Marami kang matututunan doon. Panoorin mo.
Sige nga, patingin.
Ito ba yun?
Patingin.
Yan. Effective yan. Panoorin mo ha.
Ano?
Ngayon, tatalakayin natin ang stress. Stress is the internal resistance or counterforce of a material to the distorting effects of an external force or load. These counterforces tend to return the atoms to their normal positions. The total resistance developed is equal to external load. This resistance is known as stress. Meron tayong tinatawag na stress, and if the stresses are uniformly distributed, there is normal or actual stress and shear stress. Magbibigay ako ng isang problem at tutukuyin natin ang normal stress nito. So problem number 1. The bar ABC consists of two cylindrical segments with different lengths and cross-sectional areas. Actual loads are applied as shown. Calculate the normal stress in each segment. So meron tayong dalawang segment, which is ang segment AB at BC. Uunahin muna natin ang segment AB. Using normal stress or actual stress formula, uunahin muna natin kung ano or ang mga summation ng forces. Meron lang tayong dalawang force dito. Ito yung 4,000 pounds at PAB. Then, isasubstitute lang natin sa actual stress equation ang mga nakuha natin given. Ang force ng AB at ang area na nito, which is yung 1.2 inches squared. Makukuha na natin ang normal force nito which is in 3,333.33 PSI. Tulad din ng una, hatiin lang natin ang segment BC sa gitna nito. So meron tayong mga forces na 4,000 pounds, 9,000 pounds at ang PBC. So, nakuha na natin ang value ng PBC natin which is yung 5,000 pounds. Substitute lang natin sa formula nating normal stress. At ang area nito is 1.8 inches squared. Ngayon, makukuha na natin ang normal stress nito which is yung 2,777.778 PSI.
We've learned a lot from our experts. Stay tuned for more insights sa susunod naming video. Thanks for watching! Bye!
Totoo lang, ayoko na eh.
Special vlog.
Ay, totoo lang, ayoko na eh. Joke lang.
Nang-play na kanina ba?
So hi guys, welcome to
Hindi, ito.
Ano to sa inyo talaga, obligated?